Hi there. A pretty common question that I get is, what is Kubernetes? In this video, I will try to explain that. If we look at the homepage of Kubernetes, we see that Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. That is a pretty good definition of what Kubernetes is, but unfortunately it doesn't give a good picture of what it actually is. I think a better path towards that is to first answer the question, why is there Kubernetes? Let's have a look at the short and simplified interpretation of the history up till Kubernetes. So not so long ago, it was pretty common to have these large monolithic applications. Basically have one artifact that would contain all the code and all the necessary instructions to run the application or the service, and this could get quite big. It could have very well been a Java jar that would be hundreds of megs, and it would contain not just the code for the service, but also the one of the dependencies. And this jar file would most likely be deployed manually or semi-manually to a virtual machine. Usually someone would have to connect to the virtual machine, install all the dependencies needed for running the application, like Java and so on, and then it would start the binary, and that was it. This meant that creating environments would be a lot of manual work. And although there were, and there still are, configuration management and infrastructure as code tools like Puppet and Chef and Ansible, they didn't quite solve the problem. So local development environments would be quite different from the stage or production environments, which would make things a bit difficult, especially when it comes to reproducing issues that appear in production. And yeah, the phrase "works on my machine," it was pretty common back then. Thankfully, Docker was created, and Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. So Docker allowed you to package the application with all the parts that it needs and deploy it as one package. So you no longer have to set things up on the host except installing Docker. Everything else would be included in the container. So that meant that you could now ship your dev machine to production. And that was great. But unfortunately, around this time, things got a bit more complicated because microservices became a thing. Microservices are also an architectural style that structures an application as a collection of services that are highly maintainable and testable, loosely coupled, independently deployable, organized around business capabilities, and owned by a small team. So what this meant was that instead of having the monolith, which include all the components of the service or of the application, you would have several smaller services built around the specific part of functionality of the bigger service. And those microservices would communicate over the network. Now, I will not comment how effective this approach was to solve the initial purpose, but one of the things that did do was that it increased a lot the number of Docker containers you had to manage, because everyone started splitting their monoliths, and all of a sudden you have microservices everywhere. And this meant that instead of having to deploy one or two Docker containers, you had to deploy tens of them. And this is quite a complicated task to do, especially if the tools that are available are rather primitive for this. Think about the situation where you would want to, for example, scale a service differently than the others. Maybe some of the services get more load than the others, and then you need to scale them in a different way. And this was one of the purposes for Kubernetes. So I hope that if we look back at the original definition that I showed in the beginning, this makes more sense now. And if we look at Kubernetes and what it is, I see it mainly composed of two logical components, the master and the workers. And to give you an imperfect analogy, we could see the master as the brain, our brain, and the workers as the other parts of our body that our brain controls. And I say that this is an imperfect analogy because, well, the master can have multiple instances, although they behave just as one. And the second point is that the clusters and the workers can continue functioning even if the master is down, which, well, in real life that doesn't really work. There could be several workers connected to the master. And if we look at the master itself, it includes, besides other components, the API server, which is basically the way the cluster communicates to the exterior, but also how communication happens between its components inside of the cluster. The second component that I'd like to mention is etcd, which is a key value database where the state of the cluster is kept. So the master basically handles all the interaction with the cluster and also manages and everything that happens inside it and stores the state. So this is the way the cluster knows where everything is being deployed and with what parameters and so on. If we look at the worker, which is basically a VM, it's composed of several Kubernetes processes, and it's being divided in pods. So on each worker node there are a number of pods, and each pod can contain one or more Docker containers. And the services that we want to deploy in a cluster are basically running in these containers in here, inside of a pod. So when we deploy a service, we tell Kubernetes what is the end state we want for that service. We do that basically through a bunch of YAML files that we send to the API. And in those files, we say like what is the Docker image name and what version we want for this, and what namespace should the service be deployed, how many instances we want to have running, and eventually how we would want to expose this service outside of the cluster. And if the Kubernetes cluster has the resources available, it will make it happen. It will usually try to spread the instances or the pods along its worker nodes. But if it doesn't have enough resources, then it might just put all of them in the same node. So it could look something like this, where this being our service being deployed on different nodes. And before I close this explanation, one of other things I wanted to mention are the namespaces. So there is another dimension to how the services are being deployed. The pods are not just, or the instances are not just spread over nodes, but they're also grouped into namespaces. And it's not just pods. Many Kubernetes resources are organized in namespaces. And the namespaces provide basically an isolation between the resources in the cluster. It allows us to assign roles to the users connecting to the cluster and to give them access to do specific actions on specific namespaces. So if we look at our service, it's being deployed into the cool namespaces, and well, the cool namespace and the namespace spreads across the nodes. The same with kube system namespace, which is the namespace where the core Kubernetes pods are being deployed usually. And in reality, pods might look a bit like this when it comes to namespace distribution across nodes. So if we look at this picture, the rectangles are pods of different sizes, and the colors represent the namespace they are part of. So it's always a mix. Based on the requirements that we give to Kubernetes and what is the best way it sees to use the resources available in the cluster. And that being said, I hope this gave you a better picture of what and why is there Kubernetes. Thank you. Bye-bye.